Okay. Haha, it's not echoing. For 1.3, we're going to solve equations. So that means equations means we have equal signs, right? Hey, yay. Okay. So we've got just 2 vocabulary things today, and they're right off the bat here. First is the solution to an equation. So when we say solution to the equation, we mean a number can't write. Okay. Retry. Hello. A number, comma, with which we can replace the variable. Huh?
The stadium looks amazing.
Oh. To make an equation true. Whew. So basically, when we have an equation, it has variables in it. When we say the solution, we're talking about the numbers that we plug in for the variables, and it makes the equation true, meaning the right side equals the left side. It's a true thing. Okay? That's the solution. So it's the number we can plug in that makes it true. Now, the directive word for this, what the book is going to tell you to do is to solve. Yesterday, we evaluated expressions. Today, we are solving equations. So when I say solve, I mean find the solution to the equation. Find that number we can plug in. Okay, so solve means find the solution to the equation. Okay, and like what you do with that, we need to get the needed variable by itself. That's our goal. Alright, so we're going to look, see what is close to the variable, what we need. It needs to move away from the variable until the variable is by itself. Now we're going to have to look and see what that's going to take, but we can use all these properties that we learned the other day. Okay, all the ones with arrows coming out, we talked about those in 1.1. So if you need more examples, go back to 1.1. Alright, that was associative property, distributive property, all that. Now, there's 2 of them that are added in. The more simple one is this very bottom one. Multiplication property of 0. Basically, if you multiply anything by 0, the answer is 0. Okay? That's it. Okay. Just remembering that. The other one is this quotient property. That's the other new one. Okay? And you understand this, that we can take a number times a fraction and we just multiply that number in the numerator together and it becomes one fraction. But remember, you can also do the opposite if you need to. If you have a fraction and you want to break it apart, pull the numerator out to the front and then you can just replace the numerator with 1. Okay, it goes both ways. So we can use those if we need to. Now this list, it's really, if you get stuck on a problem and you're not sure what to do, maybe go back to this list, find something that looks maybe similar and try that. Okay, it's just here to help you. So let's try the first one. Solving an equation with variables on both sides. So we're going to solve 13y plus 48 equals 8y minus 47. So what's our variable here? Y. So we need to get y alone. Or basically our answer needs to be y equals and then everything else. So what do we need to move? Let's look at this side. We need to move things away from y. Start with the things farthest away. So over here, Let's move it to the other side. How do we move 48 to the other side? Subtract it. Do the opposite of what's happening. It's being added, so we're going to subtract it. So we subtract it from this side, and we subtract it from the other side. And that leaves us with 13y equals 8y minus 95, I believe. Alright, now let's try to get all of our y's in the same place. So what should we do with that 8y? Subtract it again. It was also being added, so we're going to subtract it. We have like terms on our left side. 13 minus 8 gives us 5y equals negative 95. Now the only problem that we have is that our 5 is still by our y. What's happening between the 5 and the y? Multiplication. So we need to divide, the opposite. Okay. So we divide both sides by y, or by 5. Those 5 cancel. We get y equals negative 19. Is that right? Y'all just gonna trust me, or is it really right? Okay. So make sure when you're solving things that the answer is like variable equals and whatever the answer is. Don't just put negative 19, because I don't know what that means, but if it's y equals negative 19, I know what that context is, I know what it means. So make sure you put like y equals or x equals or whatever. All right, any questions? Familiar? Done this before? Okay, this one, what variable are we trying to get? X. Okay, so we need x equals. That's what we're trying to find. Get x by itself. But we got parentheses. So how should we deal with those? Distribute first. Okay, we're going to distribute negative 7 on that side and 3 on this side. Yep, so we'll have 3x minus 14x. Plus, I think it's 91.
Is that added or?
Yeah. It's added because it was a negative times a negative. It makes it positive. Equals
6x plus 27.
plus 27. All right. What do y'all want to do first?
Maybe add 6 on the 27 side.
Okay. So we're going to add the 6x from the right side. We'll put it over here.
On the negative 14.
Yeah.
You gotta make it like 8.
We-
Make it 8.
Yeah, we can combine all of these, can't we? They're all like terms?
So that make it negative 5, or, yeah, negative 5.
Yeah, okay, so we get negative 5x. So we just added all those coefficients together. 3, 6, and negative 14. Okay, plus 91 equals 27.
So we gotta subtract that 91,
Mm-hmm.
and then whatever 91 minus 27 is, and we put the negative sign.
36. Negative 76.
64, I think.
I don't know.
Does nobody have a calculator? Oh my goodness. Negative 64. Paul confirmed.
And then you guys divide it.
All right.
Negative 5.
Divide. Hey, pay attention as he's getting calculators because he's nice.
5 times 9. So 13.
So as Osmar is passing out calculators, Tanyan finished the problem
Well, it's a little.
pretty much. Okay, so the negatives divided by negative, those cancel each other out. Can we reduce 64 over 5? Fraction-wise? Is 64 divisible by 5?
No.
No. So if you want to leave it as a fraction, go for it, as long as it's reduced. Or it could be a decimal. What's that decimal? All you calculator people.
I don't know it right now. It's
12.8. I will accept either one of those. They're both true answers.
if we're rounded, I would have been right.
Any questions on these solving problems? No? All right. Whew. Woo! Example 3. This time we have more than one variable, so we have to read to figure out which one it wants us to solve for. The formula for the area of a trapezoid is A equals 1/2 h times b1 plus b2. Solve the formula for h. So we're going to end up with h equals. Now, just like a fundamentals thing here, the b1 plus b2, do y'all know what those little numbers are called that are down below? Subscripts.
Yeah,
They're subscripts, okay? Those are not exponents. They really, really, really and truly, they are just names. Okay, they're not like math, like operations. They're just names. Yeah, they're saying on a trapezoid, there's the first base on top, which is usually shorter, and then the second base on bottom, which is longer. Okay, so they're two different things. B1, they are not like terms. B1 does not equal B2. Okay, we cannot combine them. They're just names. Okay, we could have used totally different letters. Same thing. All right. Now, let's solve for h. Okay, so we have a equals 1/2 times h times b1 plus b2. So we kind of have two things that are attached to h that we need to move. We need to move the 1/2 and we need to move this parenthesis thing. Which one y'all want to do first? 1/2.
Which is divided by 2 or something, like reciprocal or something.
Kind of. Well, since it's a fraction, what's like really, we've got 1 divided by 2. Okay, so we're going to multiply by 2. We're going to multiply by the reciprocal. You're right. Okay, so multiply by 2. If we multiply the right side by 2, got to multiply left side by 2. So we have 2a equals, oops, I don't need that 1/2 anymore because they canceled.
2a equals 2h.
Just h times b1 plus b2. Okay, so now we've got this whole parenthesis thing. We can treat that as all one thing because what's the operation between h and all of that? Multiply. So we should divide by the entire thing. And that'll cancel, but we got to do it to the other side too. So then h equals 2a divided by
Over
b1 plus b2. And we have our answer. Okay, so when you've got things like this, just pick out one thing at a time, get rid of that. Okay, move it to the other side, then pick the next thing out, move that. Okay, look at it as one thing at a time. Okay, any questions? All right, I'm just going to tell you up front. This next one's a little rough. Okay, solve x divided by a plus 1 equals x divided by b for x. So we need x by itself. Find any restrictions on a or b. The restrictions part, we're going to deal with that at the end, okay? But we can't forget to come back to it, okay? So don't let me forget. Now, we got to solve for x. Okay, so x divided by a plus 1 equals x divided by b. Whee. We've got x's on both sides, so, and we have one of them's divided by a and one of them's divided by b. Do y'all want to handle the a or the b first? Doesn't really matter.
Definitely the b.
Definitely the b. Okay, so over here with the b, it's divided by b, so what do we need to do? Multiply by b. If we multiply the entire left side by b, we got to multiply the entire right side, so we need some parentheses over there. Okay, and so those b's cancel, but what do we need to do with b on the right side now? Distribute it in there. Okay, so we're going to have bx over a plus 1 times b is just b, and that's going to equal x. Now we do have x equals, but is that the only x?
No.
No, we still have an x on the other side, so we're not done yet. Okay, now we gotta deal with the a. And it's being divided, so we're going to multiply. But we can't just multiply that one part, we gotta multiply everything. Okay, so let's multiply everything by a. And that means we gotta multiply the other side by a. What? And we're gonna distribute that a in, it'll work, I promise.
So ABX.
ABX over A plus
ABD.
AB equals AX. I put them in alphabetical order. Okay, in that fraction, what happens to the A's? They cancel. Yay, that's what we needed. Okay, we're doing good.
So BX plus AB.
Equals AX. Let's get all the x's on one side. So let's move the bx to the other side by subtracting it.
Yeah.
So we have AB equals AX minus BX. Our x's are together, but there's still two of them. So, just like over here, how we put the a into both terms, and so down here there's an a in the first term and a in the second term, we're going to do the opposite. We've got x's in both terms, so we're going to pull it out to the front. We're going to undistribute. Okay, I don't know a more official word than that. Okay, so we're going to pull both of these x's out to the front, so it'll look like AB equals x parentheses and then what's left. If we pull both those x's out, A minus B. We're doing good. One more step and we'll have it solved. What do we need to move?
Divided by A minus B.
Yes, we're going to divide both sides by A minus B. Divide by A minus B. So x equals A minus,
AB divided
whoops.
by A minus B.
yeah,
Problem's impossible.
A, B divided by A minus B.
Yeah, if there's one of these on our homework, I'm probably just gonna skip it.
Okay, and then you'll come in and ask questions, or do that one first, and then we can work it together in here. Okay. What did I say we have to come back to at the end? Restrictions. Okay. Restrictions are like things you can't do, right? Okay, if your like physical therapist puts restrictions on you, they say you can't, lift weights over your head or lift weights more than 100 pounds or something. Okay, so we need to know our restrictions. That means what can A or B not be? As in, what value can they not have? Okay, so these are restrictions. On your homework, you don't have to label restrictions, but I'm writing it on here so that when you come back later and you're like, what was going on right there? You'll know. Okay, so we know one thing that cannot happen in math. What is it? What can't be zero? Denominator. Remember, calculator blows up, paper catches on fire. So what is our denominator?
A minus B.
So A minus B cannot equal 0. Okay, that's a good start, but we need to know specifically, so what can A not be? So let's solve for A. So we need to
A
move...
can't be 1.
No, okay, let's move the minus B, so we're going to add it to the other side. So A can't equal
B.
B. That's your restriction. Okay, so those two together are your answer. If A equaled B, so say they're both 1, 1 minus 1 equals 0. Or both 300, 300 minus 300 equals 0. Okay, so that is when the problem doesn't work. So we have to write that down.
See, that's what I was getting
That's where you were gonna, Okay?
That were sons of love. Forgot.
Okay. Now, 2 more problems. Okay, a dog kennel owner has 100 feet of fencing to enclose a rectangular dog run. She wants it to be 5 times as long as it is wide. Find the dimensions of the dog run. Okay, well, first of all, enjoy this. Sorry. Okay. I just thought it was funny. Okay. So what do we know? We know how much fence do we have to work with? 100 feet. So if we have the 100 feet to go all the way around, what is like that value? It's not the area. It's the perimeter. Okay, so that's our perimeter. So we know that the whole thing around needs to be 100 feet. She wants it to be 5 times as long as it is wide. So let's call this our width, and then the long side will be our length. Right? So that whole 5 times as long as it is wide. So if width is W, then length is going to be,
L times 5.
well, huh? 5 times W. Length is going to be 5 times as wide. Okay, so 5 times width. Very good. And we got to find the dimensions spelled incorrectly.
Wow.
It's not how you spell dimensions.
I was wondering, I was like.
Yeah, my bad. Sorry. Okay, so how can we use the information we have to figure out what length is and what width is? Those are the dimensions. We know length is 5 times W, and we know we have 100.
6W equals 100 or something?
Close. So perimeter is all the way around, right?
Yeah.
So we've got,
2L equals 5, 2 at 5 W's and just 2 W's.
yeah, so the basic formula for perimeter is length plus width plus width, right? And so that's going to equal our 100. We can combine some like terms there. So 2L plus 2W equals 100. And right now we have 2 variables, but we can use our 5W up there and replace this L, right? So 2 times 5W, this is going to get to where you were going a second ago, Levi.
10W, 12W.
10W plus 2W equals 100, so
100 divided by 12.
12W equals 100. So W equals
So W equals
8.3, or if you want to do it as a fraction, let's see, 100 divided by 12 reduces to 25 over 3. Do y'all know how to use a calculator to reduce? The math, enter, and it goes to fractions and reduces it for you. Math, enter. Okay. All right, so we know width. What's the dimension, not the dimensions, the units for width? We're going like feet, okay. So that equals W. Okay, so that's half of our answer. Now how can we use that to find length?
We can plug it in.
Plug it in. So length is 5W. So length will be 5 times 25 over 3.
So it's 8.3 times 5.
Yeah, you can do decimals or fractions. 5 times 25, if you have 5 quarters, you have $1.25 over 3. And we've got feet again. Okay, so it's, what'd you say? It's 8.3 and 41.5 if you did decimals. And now we've made our happy dog even happier because he has a home or something. Or he's able to go outside. He's crazy.
He's probably feels like he's more in prison.
Ah. Sometimes I feel like that. He's cute, but not pretty. Okay. All right, last one. You awake? Yes, slap yourself on the head 5 times so you'll be awake.
No.
No one did it? Oh. Okay. Wait, tap yourself. Okay. The lengths of sides of a triangle are in the ratio 3 to 4 to 5. Does that necessarily mean the lengths are 3, 4, and 5? That just means when they're related to each other, the ratio is 3 to 4 to 5. Okay, the perimeter of the triangle is 18. Find the lengths of the sides. So which one is the shortest side, it looks like?
Definitely the left side.
The up and down one? Up and down? Okay, so we're going to call that the 3. We're going to put with that. But remember, it's not necessarily 3. It's 3 times some, like, factor. And we're going to call that x. Okay, and then the next side,
The 4 is the bottom.
the bottom, so that'll be 4x. The
There
hypotenuse
we go.
is 5x. All right, and then we know the perimeter is 18, so how can we use that?
Put 18 in the middle of it.
Yeah.
That's what I usually do.
Okay, who said something else? What'd you say? Yeah, all those sides add up to be 18, so we're gonna write that out.
See, I like to put in the middle side though.
Okay,
And now I put it like that.
okay, I usually put area in the middle, but that's cool.
So smart.
You are all so smart. Okay, do we have like terms? Yeah, they are
7 plus 5, so 12.
12x equals 18.
Whatever.
X equals what?
18 over 12. Or, hold on.
1.5.
Yeah.
Okay, 1.5. Now, does that tell us our answer?
No.
That's just the.
That's just like our factor, okay? So we can use that though, right?
Multiply. Yeah.
Very good. Okay, so
3.5.
3x.
No, I'm off.
What's 3 times 1.5? 4.5. Okay, so what's 4x? It's going to be 4 times 1.5, which is,
5. No. I don't know. I need a calculator.
I think it's 6. Because 4 plus a half of 4, yeah. Okay, and then 5x, it's going to be 5 times 1.5, which is
7.5 or something.
7.5.
Dude, I can't do math in my head now that I've used a register for so long. I can't. Like, I used to be able to count. I used to be really good at it, and I tried to do it the other day, and I couldn't do it.
That's interesting.
Is
Good
that
job.
what-
Okay, but this word problem, there's units. What are they? Inches. They're all inches. Okay, so we found all the sides. Those are our answers.
That's the inch.
That's the inch. Okay,
We done.
we done. You've got, what time we get out of here? 43? You've got 12 minutes to work on stuff. And remember,
Go to the bath.
some of them, yes, thank you for waiting till we were done. Some of the problems are going to be hard, so you should probably work on them so I can answer questions, because come Monday night or Tuesday morning, oh, yeah, when you're doing homework, it's okay, it'll be on there. Then you're probably going to have forgotten, right? So maybe work on it now.
We can just look on the YouTube channel.
Okay, that's true. I'll stop it now.